Hello guys and welcome to Engineering Canada. In this tutorial I'll basically be going through statistics and probability introduction, and then from then we're gonna gather up from we're gonna be basically building up the concepts. So I'll be dividing the book. Basically I'll be starting with statistics and we'll be going to probability, and that's how the book is basically designed. And let's get started then. In this episode, I'll only be covering an introduction and some definitions, and then we'll try to solve problems in future episodes. But for now, I want to discuss the first concept and of statistics, and that will be the concept of simple random sampling. That's SRS, simple random sampling. So what is simple random sampling? Alright, so simple random sampling is a term that comes when you describe the probability or the chance of having an element being selected. Uh, the element that's being selected has the same chance as any other element from that sample. So when you so basically, what does this all mean? So basically, what I'm trying to say is that the chances of picking up a ball, or no, let's take the ball away from the equation. The chance of picking up a person, assuming these population here, with the same political view is almost the same, right? So probably all farmers have the same political views. And now, assuming you pick a farmer and you pick a simple farmer and another farmer, when we say that they're in simple random sampling, it means both of them will have the same point of view of political view. Now, let's take this scenario to people living in the city. Now, people living in the city are going to have different political views than those who are living in the farms, right? Most certainly. So when we say simple random sampling, we are going to only take samples on political views of people either living in the city or living in the farm. And this is what basically simple random sampling means. Because if you pick this lady here and this lady here in a simple randoming scenario, both of them are going to have the same political view. If you pick any of these people, they're gonna have the same political view, and this is what simple random sampling is. Now, the question that comes into mind here is, why do we need simple random sampling? Why would you want to do that? And of course, from logic, it tells us the reason why we wanted to take these people and sample them, and then go to these people and sample them and not put them together in the same sample, is to eliminate differences in the population. So you don't want to go to you don't want to go and take 1,000 samples of people living in the city with a political view and consider it a vote of whole of America, right? No, that's not how it works, because other people with different, mindset, other ethnicity, other occupations, they have different political views than those living in the city, for instance, right? So obviously they're gonna have a conflict here. So a simple random sampling solves this by taking those group of people and sampling them. Now the issue comes here is that now we're in the United States, right? We have issues with politicals all the time. Right? We're here in Canada, but I normally say we're in the U.S. because they're right beside us, and they're the people with the most political interest. And when we say that we want to sample the population of the U.S. on their political views, so what do? We can't. Logic says we cannot take only farmers and take their political views. We cannot take people live in the city and consider the whole political view. No. So what we do is something called stratified random sampling. So stratified random sampling is that you gather all the farmers, take their political view. You gather all the people who live in the city and take their political views, and the rest of the people, they have the same political view. So this lady here has the same chance of having the same political view as this guy here, as this guy, whatever, but not the same chance of having the same political view as this guy here, right? So this is what stratified random sampling is. And let me put in better terms. So simple random sampling, you have a bunch of people here. The chance of that you pick this guy and this guy with the same political view is the same, right? Now you have striated random sampling, and now you have stratas. Now I forgot to mention, stratas are basically, so this is a strata. Right, terrible handwriting, right? So this is a strata, this is a strata, and this is a strata, okay? So this is what a strata is. Now, the reason that now we need to talk about this is because we're gonna get into a concept known as data types, also known as variables. Now, the types of data can either be quantitative or qualitative. Now, when we talk about quantitative data, we need to put into consideration what are the subsets of quantitative data. Now, quantitative data is either discrete or continuous. But right now, let's focus on quantitative on its own, then we go to the subset. So what is quantitative data? Quantitative data is basically results that only deal with numbers. So quantitative, you only deal with number. You deal with quantity, right? It's from the word quantitative. You deal with quantity. So 6, 7, 8, 9, 0. These are all quantitative results. Now, assuming we have these numbers as our results in a sample, right? 6, 7, 8, 9, and 0. Now, these numbers, if you realize, they are full numbers. They're integers. You don't have 6.5, 6.2, 7.4, etc. It's full numbers, either 6 or 7. Now, these types of data are considered discrete data. The reason they're discrete is that you can't have fractions. It's either full number. Now, the other type of data is that I don't have it. It's either, yeah, it's here. The other type of data is what is basically called continuous data. So continuous data deals with data that is in a range, right? So you have 75 to 100%, but you can have 75.4, 75.5. You can have 92.5, 92.6. These, you can have fractions, right? So these types of data are basically called continuous data. Now, going back to, so these are the subsets of quantitative data. So quantitative data can either have discrete, or you can have continuous. Now, the other type of data is called qualitative data. Qualitative data either live with only quality, so either a yes or a no, either a pass or a fail. So these are examples of, see the grades here? These are all examples of qualitative. See, these are all qualities. They don't deal with numbers. Now these numbers in here, they deal with qualitative. So sorry, with quantity. They deal with quantitative results, right? So these are quantity from quantitative. Well, so these are quantitative results, and these are qualitative results. Now, qualitative results is anything that's not number. So if you're gonna like take a simple, let's take this as an example. So from 2009 results, we can see that numbers are 62, but we come here and see it's a 43.8. So what type of data is this? So this type of data is, obviously we can say it's quantitative because it deals with quantities, numbers here. So what type of quantitative? Is it discrete or is it continuous? Well, apparently there's a decimal in here, so 43.8 is part of data, so it's continuous data. Same with here, there's a decimal, continuous data. Now, well, all the data in here are continuous, so these are all continuous data. Now we'll take a look in here. You have the grade point average, you have one, see, these are all quantitative. Now, let's take a look at the grades and the descriptor. What type of data are these? Now, these are not numbers, as you can see here. Well, A1, there is a number, but it's not a number. It's not, you're not categorizing it by number, you're categorizing by grade. It's like A1, it's like A plus, A2. I don't know their system there, but basically these are all qualitative because it's a descriptor, right? It's you being categorized. So if you get 7500, you categorize under the grade of A, and the descriptor here, it's not number, right? So it's considered quantitative. Now that's it, and in the next tutorial I'm gonna cover more examples, and I'm gonna cover actual questions from the book. Now, thank you, and see you.